I'm Joerg Fischer-Buehner. I'm in the industry for precious metal R&D since about 25 years, and I'm with Indutherm, responsible for R&D since about 15 years. The longest experience and history we have with gas atomizers. Gas atomization has the potential to create spherical powders in very different size ranges by varying process parameters. And with the ultrasonic systems, we are a little bit more limited with the parameters that we can vary. We can create also very, very spherical particles. Gas atomization, as opposed to water atomization, is, well, in one case we use gas, in the other case we use water. So water obviously is the cheaper medium to create powders. The downside is in water atomization we usually produce non-spherical particles. Our first units were designed for gold and silver and copper-based alloys and using graphite crucibles. Graphite crucible is a wonderful material also used for jewelry casting on a daily basis. It works perfectly for these types of metals and also in an atomization process. So going to higher temperatures, it was a two-step process for us. We first wanted to accomplish the temperature range, and here we talk about ceramic crucibles based on aluminum oxide. So we require to understand also how to work safely and efficiently at these temperature ranges. Then to acquire and accomplish the higher temperatures that we need for platinum was another long story and process. We had to identify the right ceramics based on zirconium oxide. These have the potential to stand the temperature range 2000 degrees and above that we need for platinum. This is another challenge, talking about the yield that we have in an atomization process. Yield is defined as the percentage of usable powder in a specific size range that are then required for the different printing processes that are around. In gold and silver powder atomization processes, we are able to achieve yields in the range of 70% or even above. For platinum atomization, at the status where we are at the moment, we know we can arrive at yields above 50%, and there is potential for further improvement. The oversize and undersize that you remove from an atomized batch by sieving and classification processes, this powder can be remelted and reused. Of course, you have to pay attention to the contamination, you have to do your analysis on the powder, but it's potentially possible because all the process steps are carried out under protective atmosphere, so the amount of contamination by oxidation is limited. So post-processing of the powder is very important to extract the usable size fraction and to make the powder flowable. So the system that we are offering for the post-processing step is a so-called air classifier that separates coarse from fine powder at different size regimes in a gas flow environment. So different to a sieving process where you work with discrete meshes. In this air classification process, you are having the opportunity to continuously shift the cut point from basically 3 micron up to 100 micron or above. So that's a very convenient tool to fine-tune the properties and the fraction of the powder that you are going to use in the printing process. For platinum, we so far have worked on powders for laser powder bed fusion and binder jetting. So for laser powder bed fusion, we are targeting at an average particle size around 25, 30, 40 micron depending on the printers. And for the binder jetting processes, we look at particle sizes more below 25 micron. So the nice thing with the gas atomization again is that you can atomize into these size ranges. Obviously, everyone is afraid of losses when it comes to handling very fine powders. Yeah? The first requests we got when we were approached by potential clients was, can you guarantee losses lower than 0.5%? And at that point, we were not sure. The good news is, when we started to work on our atomizer, we have, from the beginning, looked at very good clean out and very low losses. So the system was, from the beginning, designed for that, using high polished surfaces wherever possible and avoiding undercuts and traps or powder can be lost. So we can now say, from the experience that we have on platinum atomization, that the losses that we have in the range of 0.1, 0.2%. This, I think, is very good news.
That's wonderful. That's a huge benefit, specifically for the jewelry industry, but even the industrial industry at large.